Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss two UGC NET questions which came in the year 2018. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. In which of the following scheduling criteria context switch will never takes place? They have given four options. Option A is round robin scheduling algorithm. Option B is preemptive shortest job first scheduling algorithm. Option C is non-preemptive shortest job first scheduling algorithm. And the option D is preemptive priority scheduling algorithm. We need to solve the question and find out what is the right answer. First, if you look at the option A, round robin scheduling algorithm. Any scheduling algorithm, we will have two important parameters. One is the criteria and another one is mode. Now the criteria for the round robin scheduling algorithm is the time quantum. Is it clear? First it will execute the process which come first, then after the particular time quantum is completed, it will preempt the process from the running state to the ready state. Okay, so the mode here we need to talk. The mode here is preemptive scheduling algorithm. The round robin is preemptive scheduling algorithm. Let me discuss with a simple example. Let's take the time quantum is 2 units. Okay, meaning of that one is even if the process requires more burst time than the 2 units, it will execute for only 2 units and then it will be preempted to the ready state. Meaning is that let's take the process P1 needs 5 units of CPU time to complete its task. Now let's take that in the ready state and running state. This is the ready state and in the running state. Okay. Now process P1 and process P2 are there in the ready state. Now process P1 came first, then process P2. Then process P1 will be dispatched to the running state and process P2 will be there in the ready state. Even the process P1 needs 5 units of CPU time to complete its task, but as the time quantum is specified as 2 units, process P1 will run for 2 units. Okay, then it will be dispatched to the or sent back to the ready state. Is it clear? Then process P2 will come and will run for 2 units of time and then it will be sent. So even if the process needs more burst time, it will run for particular time quantum, then it will be preempted. So the round robin scheduling algorithm is a preemptive scheduling algorithm. Now look at here, the option B. Is it clear? For us, the mode is very important. Okay, round robin is a preemptive scheduling algorithm. We have two types of scheduling algorithms. One is preemptive and another one is non-preemptive. Now look at the option B, preemptive shortest job first scheduling algorithm. Preemptive shortest job first scheduling algorithm is even called as shortest remaining time first scheduling algorithm. So for shortest remaining time first scheduling algorithm, okay, the criteria is burst time. The process which has the less burst time will given high priority to dispatch to the running state and the mode is preemptive. Is it clear? Okay, the name itself is saying that it is a preemptive. So it is a preemptive scheduling algorithm. Now look at the shortest job first scheduling algorithm. The shortest job first scheduling algorithm, the criteria is burst time. The process which has the less burst time will given high priority, same as the shortest remaining time first scheduling algorithm. But coming to the mode, it is a non-preemptive scheduling algorithm. Is it clear? Are you able to understand what is meant by non-preemptive scheduling algorithm? Let's take that in ready state, process P1 and process P2 are there. Now there is a running state. Now let's take that process P1 needs 5 units of CPU time, process P2 needs 7 units of CPU time. Now among the process which are there in the ready state, which has the less burst time, process P1. So process P1 will be dispatched to the running state. It needs CPU 5 units. So it will complete the 5 units. then it will go to the terminated state. So meaning is that when the process P1 is running, the CPU will not preempt the process and send to the ready state. So it is a non-preemptive scheduling algorithm. Once the process comes to the running state, if it does not need any IO, it will run for the amount of time, how much burst time it is required, then it will go to the terminated state. Here we are assuming that none of the scheduling algorithm requires the IO. If even this process P1 needs IO, then it will go to the suspended state. Is it clear? Now look at here. So what I want to say is that shortest job first scheduling algorithm is non-preemptive. Then preemptive priority based scheduling algorithm. Now preemptive priority based, the criteria is priority. The process which has the highest priority will be given highest priority to dispatch to the running state. And the mode is, the name itself is saying preemptive. Now why I am giving the more importance to the mode is that you will understand in which of the scheduling criteria context switch will never takes place. Whenever there is a preemptive scheduling algorithm, look at here, when we discussed about the round robin scheduling algorithm also, we said time quantum is 2 units. Even if the process P1 needs 5 units and it is running in the running state, it will run only for 2 units and then it will be sent to the ready state. The process which is there in the ready state will go to the running state. So this entire process we will call it as context switching. The process which is there in the running state go into the ready state, and the one of the process which is there in the ready state coming to the running state. This entire process we will call it as context switching. When the context switch will happen, if the scheduling algorithm is preemptive scheduling algorithm. If it is a non-preemptive scheduling algorithm, the context switch will never takes place. So their question is, context switch will never takes place. Round robin is a preemptive scheduling algorithm, so their context switch will happen. Okay, so this is not the right answer. Option B, preemptive shortest job, which is nothing but shortest remaining time for scheduling algorithm. The mode is preemptive, so here also context switch will happen. Now option C, non-preemptive shortest job. So the name itself is saying non-preemptive. So option C is correct and option D is preemptive. Even option D is also wrong. So in non-preemptive shortest job scheduling algorithm only, context switch will never takes place. Is it clear? So the right answer for this question is option C. I hope you have understood how I solve this question. Now look at the second question. Suppose P, Q are cooperating process satisfying mutual exclusion condition. Then if the process Q is executing in its critical session, then they have given 4 options. Option A, P executes in critical session. B, R executes in critical session. Option C, neither P nor R executes in critical session. Option D, both P and R executes in critical session. Now we need to solve the question and find out what is the right answer. Now to discuss this one, let me discuss the theory behind this concept. What is a mutual exclusion, what is a cooperating process, all these things. Then I will solve this question. Lot of students will think that numerical questions are very hard, but the theoretical questions only lot of students will do the mistake. Is it clear? So I request everyone to study the theory properly. If you study the theory properly, then you can easily crack the UGC NET exam. Okay, now look at here. They are talking about the cooperating process. We have 2 types of process. One is the cooperating process, and then independent process. First, let me discuss what is a cooperative process and what is an independent process. If it is a cooperative process, let's take that you have a process P1 and process P2. If they are sharing some resource, the resource may be a variable or maybe a code or any other device like a printer or something. Now, when the process P1 is running, it will affect the process P2 because of this shared resource. Is it clear? Are you able to understand? Process P1, when it is running, it will affect the process P2. Such kind of process we will call it as cooperative process. Coming to the independent process, the process P1 and process P2 will not share anything. So whatever the process P1 is executing, it will not affect the execution of process P2. So this is about independent process. Now when it comes to the cooperative process, in what part of the code there is a some common variable or shared variable, that part we will call it as a critical session. Now let me discuss with a simple example for you. Let's take that process P1 is there, process P2 is there. There is a common variable called count and its value is 10. And here you have written count plus plus, and here you have written count minus minus. Is it clear? Now this part we will call it as a critical session. Is it clear? Okay, now in a critical session we will have a synchronization mechanisms. The process synchronization mechanisms we will design such a way that there will be an entry session and exit session, and it will have the few important requirements. One is that any process synchronization mechanism should achieve the mutual exclusion and then progress. These are the two primary requirements. And the secondary requirements of any process synchronization mechanism is, one is the bounded wait, and the next one is it is portable, meaning is that whatever the solution you are designing, it should not be only implemented on a particular hardware or particular software or particular operating system. It should be portable. Okay, now look at here, what is the mutual exclusion? Mutual exclusion is a critical session, only one process should be there at a time. Either none of the process should be there, or if any one process is there, another process should not enter into the critical session. When one process is running the critical session, when another process runs, there will be problems. Is it clear? Are you able to understand it or not? I have discussed in detail about these problems in the need for process synchronization video. If you want, you please refer that video. Is it clear? Okay, so mutual exclusion meaning is that when a process is running, another process should not run. Is it clear? So look at here, process P, Q, R are cooperating process, and mutual exclusion condition, they are satisfying the mutual exclusion condition. What is mutual exclusion condition? When one process is there in the critical session, other process should not enter the critical session. That is what they are talking. It is satisfying the mutual exclusion condition. Then if the process Q is executing the critical session, there is a critical session is there and process Q is running in the critical session, then if mutual exclusion conditions satisfy, then process P and process Q should, process R and process P should not enter to the critical session. That only we will say that mutual exclusion is satisfying. Now look at here, P executes in critical session. If Q is already there, if P also execute, then mutual exclusion will not happen. So option A is wrong. Option B, R executes in critical session. When Q is running, no one should run, but they are saying R will execute. This is wrong. Option C, neither P nor R executes, because when Q is running in the critical session, P and R should not run their critical session. So option C is wrong. Option D, they are saying both P and R will run. If both P and R runs when Q is running in the critical session, mutual exclusion will not happen. So option D is also wrong. For this question, option C is the right answer. I hope you have understood how I solve these two questions. If you still have any doubts related to these two questions, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.